Hello everyone. Today we are going to explain about the topic ARP. First of all, what is ARP? Address Resolution Protocol. ARP is a protocol or procedure that connects an ever-changing Internet protocol IP address to a fixed physical machine address, also known as Media Access Control Address (MAC). So, what do you mean by an IP? An Internet Protocol IP address is a unique numerical identifier for every device or network that connects to the Internet. And what is MAC address? A MAC address, Media Access Control Address, is a 12-digit hexadecimal number assigned to each device connected to the network, primarily specified as a unique identifier during device manufacturing. The MAC address is often found on a device network interface card (NIC). A MAC address is required when trying to locate a device or when performing diagnostics on a network device. ஓகே. இப்ப இதுல என்ன ட்விஸ்ட்ன்னா, hello everyone. Today we are going to explain about the topic ARP. First of all, what is ARP? Address Resolution Protocol. ARP is a protocol or a procedure that connects an ever-changing Internet protocol IP address to a fixed physical machine address, also known as Media Access Control (MAC) address. Now, the command that is used for ARP is ARP hyphen A, and here you're able to see the ARP interfaces, static, dynamic. And what is IP address? An Internet Protocol IP address is a unique numerical identifier for every device or network that connects to the Internet. The command that is used for IP address is IP config, and here you're able to see the IP address of the system. And next, MAC address. Uh, a MAC address, Media Access Control Address, is a 12-digit hexadecimal number assigned to a device connected to the network, primarily specified as a unique identifier during the device manufacturing. The MAC address is often found on a device network interface card (NIC). A MAC address is required when trying to locate a device or when performing diagnostics on a network device. Now we are going to see what is RARP. The Reverse Address Resolution Protocol is a networking protocol that is used to map a physical MAC address to an Internet Protocol IP address. It is the reverse of the more commonly used Address Resolution Protocol (ARP), which maps an IP address to a MAC address.
First, type the command arp-a in the command prompt, and you will get a long list of IPs, and it is under the interface 192.168.43.222. We will find a list of IPs with both type static and dynamic here. Type ipconfig, and this is my gateway address, and this is my IP address 192.168.43.222. Then type ping and copy paste the IP address here. Now open your wireshark, search ARP here, and here you can find the list of ARP packets here. Open broadcast packet. Okay, broadcast is my ARP request, and it is an Ethernet frame. And it has source MAC address as 14D424.11.96.2b. Let's check our MAC address, ipconfig all. And our MAC address is in the name of physical address here, 14D424.11.96.2b. And Sender IP address is 192.168.43.222. Target MAC address, we don't know initially our target MAC address, so all are 0 here. And target IP address is 192.168.43.30. The host that has this IP address is going to respond. None of the other hosts are not going to respond. And okay, this is my reply packet. So here sender IP address is 192.168.43.30. That is, it's sending its MAC address to the target. That is the machine that has requested this MAC address. So this is how ARP packets works in wireshark. Open Cisco packet tracer. Now I'm going to create an four systems, that is PC0 here and PC1 and PC2 and one server here. Okay. So now I have created four systems, that is PC0, PC1, PC2 and one server. Now I'm going to create a switch. So select the switch and place it here. So now a switch is created, and using this switch I'm going to connect with all these remaining systems. So now these connections are made using this copper straight through wire. So now I'm connecting with PC0, same way connected for PC1 and for PC2 and with this server. Okay. Now name this all systems. This is 192.168.11.1, and for here it is 192.168.11.2, and for PC2 it is 192.168.11.3, and for server it is 192.168.11.4. Now go to system configuration of PC0, select desktop IP configuration and type the IP address here. So it is 192.168.11.1. So after entering the IP address, the subnet mask will automatically set. Same way do it for PC1, go to system desktop IP configuration and type 192.168.11.2. Okay, do the same for PC2, desktop IP configuration 192.168.11.3. And same for this desktop IP configuration 192.168.11.4. Okay. Now select inspect here, and we are creating an OR table for PC0, and I am placing it here. Okay, or place it here. Same way, I'm going to create an OR table for PC2. Place it here. So now start the stimulation and check whether ARP packet is here. Now we are trying to send a packet from this PC to this PC. So that is from PC0 to PC2. Now go to this, select command prompt and type ARP-A. So initially there are no ARPs found here, and now using this ping command, um, the IP address of this PC2 is 192.168.11.3. So we know the IP address of this PC2, but doesn't know the MAC address. So if we send a packet from PC0 to this PC2, so we are using this OR table. Okay. Now send this. Now two packets will be created, and one is IMCP packet and other one is ARP packet. So now start capturing here. So now from PC0 a packet is sent to switch, and from switch it again sends to server and PC1 and PC2. Now these two will not accept the packet since the target MAC address we given as PC2. PC2 will accept the packet and it's resend the packet to the PC0.
Now let's do ARP spoofing. This ARP spoofing includes an Android phone, Wi-Fi router, and Kali Linux. So Android phone requests a website through Wi-Fi router, and my Kali Linux will act as the Wi-Fi router to the Android phone, so that all the requests that I've been sending out from the Android phone will go through my system. So let me show the demo. These are the commands I'm going to use. So this is IP forwarding. It is to enable IP forwarding because we need to enable it because some packets will be going through my system. So if we do not enable this IP forwarding, it won't go to the destination. So now let me copy this command and run this. So now then we are going to use these two simple commands. Using ARP spoof, we are going to use the network adapter, that is WLAN 0, because I'm connected to the router since I'm using my wireless network adapter. So this is the address of my IP address of the Android phone, and this is my IP address. So I'm going to act as a Wi-Fi router for that Android phone, and now I'm going to act as an Android phone for the Wi-Fi router. So let me execute both of the commands. So now our ARP poisoning attack is running. We use ARP to show the ARP cache table. So this shows that for this IP address, this is the respective MAC address. Now the what will be running background is the default gateway, that is the Wi-Fi router's MAC address will be changed to my Kali Linux MAC address. So the gateway's MAC address is changed to my Kali Linux MAC address. You can use ARP for Linux and ARP-A on Windows to show the cache table, that is ARP table. Now let's go to wireshark. One second. Now I'm selecting my wireless adapter. Now we're going to check whether the ARP spoofing is working. So from my Android phone, I'm searching the serverless, that website. Now I've captured that. So let's see that the GET requests have come. So ARP spoofing have been worked correctly.